So when we add and subtract fractions, sometimes they're going to have negatives in them, and we'll be applying our integer rules and our fraction rules at the same time. So this is the basic algebraic rule for fractions written out. When you have two fractions that have the same denominator, you add the numerators and you keep the denominator. We know this very well. Just like with subtraction. If you have two fractions with same denominators and you subtract them, then you're going to subtract the numerators and keep the denominator. Only we change our subtraction to adding the opposite. So now let's dive into some problems. Let's say we have a problem like 5 1/4 minus 2 1/3. Well, we're going to change all subtraction to addition. And then we're going to use our integer rules to determine the operation. So that's our first step once we change all subtraction to addition. So I'm going to look at this problem once I change it to addition. 5 1/4 plus negative 2 1/3. I'm going to ask myself, what actually happens here? Well, we're adding different signs. So when you add different signs, you're actually going to subtract. And then we look at the signs. Well, we have more positives than we do negatives. Therefore, our answer will be positive. So we're really going to subtract these two numbers. And the answer is going to be positive. So I'm going to treat this as a subtraction problem. 5 1/4 minus 2 1/3 is going to be 5 3/12 minus 2 4/12. Now I'm going to have to regroup, so take 1 away from 5, and it becomes 4, and then I add that 1 to 3/12 as 12/12 to get 15/12. And then I just subtract, and I get 2 11/12. Let's look at another example. Here we have negative 2 1/3 plus 2/3 minus 5. So I'm going to go ahead and rewrite this using all addition. So I get negative 2 1/3 plus 2/3 plus negative 5. So all I've done is change subtraction to addition. Now, once all of the subtraction is changed to addition, it doesn't matter which numbers we add together first. According to our commutative or associative rules of addition, they state it doesn't matter which numbers you add first if you have all addition, which is one reason we change subtraction to addition. So I'm going to add my negatives together first. My negative 2 1/3 plus negative 5, because that's pretty easy, right? I can actually do that in my head. So when I do that, I'm going to add negative plus negative. And we're adding like signs, so we add the numbers and we keep the sign, which is negative. So we end up with negative 7 1/3. Easy enough. So now we're going to be adding negative 7 1/3 plus the 2/3. Well, here we're adding different signs, so we subtract. And we have more negatives than positives, so our answer will be negative. So we have 7 1/3 minus 2/3. That's actually the math we're doing, even though the original problem is negative 7 1/3 plus 2/3. What we're really doing is subtracting and keeping the sign of the greater. If it helps, go ahead and write that negative sign down so you don't forget it. And you just go ahead and treat this like a regular subtraction problem. You're going to have to borrow. And we end up with 6 2/3, and we need to remember it's negative. So that's our final answer. Go ahead and try this problem. And when you're done, check your answer. In this problem, we're adding different signs, so we need to actually subtract. We have more negatives than we do positives, so our answer is going to be negative. So I'm going to come over and complete a subtraction problem. And I'm going to go ahead and put that negative beside my answer, where my answer is going to be, so I don't forget it. So 6 1/4 minus 3 3/5. I'm going to get common denominators of 20. I'm going to have to borrow, and I end up with negative 2 13/20. Now we're going to work with addition of fractions where we have variables within the fractions. In this example, b over 6 plus 5 over 6, it looks really daunting at first, but if you keep in mind your rules for adding fractions, it's really not so bad. The rules for adding fractions are that you keep your denominator if they're the same. Do we have the same denominator? Yes, so what's our denominator and our answer going to be? 6, right? And then you just add your numerators. Well, can you add b and 5 together? No, they're not like terms, so you just have to leave it as b plus 5. So you add your numerators and keep your denominators, and your answer is b plus 5 over 6. And number 2, you're going to do the same thing. Keep your denominators, subtract your numerators, but change it to addition first. Give that one a try. You should end up with 5 plus negative 3 in your numerator, g in your denominator, so you end up with 2 over g, since 5 and negative 3 are like terms, so we can go ahead and add. In the next fraction, we can use a couple different techniques for this. The one thing I'll tell you is you cannot have a mixed number with a variable in it, so we can't just say 3b and a half like we would normally. So if this is 6 plus 1/2, we would just say that that equals 6 1/2, but we can't do that with a variable. So you're going to have to write this as an improper fraction. There's a couple ways to do it. So let's start off with one technique. We write 3b and a half, and then what we're going to do is change it to an improper fraction, the way we always change mixed numbers to improper fractions. So let's think through how we would do that with a normal problem. Like let's say we had 6 1/2. The way we change that is we would take the denominator, multiply it by the whole number, and add it to the numerator, and put all that over the denominator. So we get 2 times 6 is 12, plus 1 is 13, halves. We're going to use this same process. So in this case, we're going to multiply 2 times 3b plus 1. So 2 times 3b plus 1. Well, 2 times, you multiply before you add, 2 times 3b is 6b plus 1, and you leave that over your denominator of 2, and that's your final answer because you can't add 6b and 1. Another technique that you can use if you're interested is you can get a common denominator with both of those and then add them together. So, for example, we could say 3b over 1 plus 1/2. The common denominator is going to be 2. So we're going to multiply 3b over 1 times 2 over 2. We'll get 6b over 2 plus 1 over 2 equals 6b plus 1 over 2. So whichever technique makes the most sense to you, use that technique. That's just a second choice. This problem is similar to the last, so I'd like you to pause the video, try this, and see how you did. I'm going to show you both techniques again. In this first technique, I'm just getting the common denominator, so I'm using the second technique I showed you before. So I'm getting a common denominator of 3. Remember that I have to put x over 1 before I do that. I get a common denominator of 3 by multiplying 3 over 3 times x over 1. I get 2x plus 3x over 3, and that equals 5x. Add the numerators, keep the denominator. The other technique was taking the fraction 2x plus 3 over 3 plus x and changing it to a mixed number, so that would be x and 2x over 3. And then you multiply 3 times x plus the 2x and leave it over the denominator, so you get 3x plus 2x, and that also equals 5x over 3. Either one of those techniques is fine.